so we should get started.
30 seconds. Good.
Go. Our clock is
All right. Welcome to HTML5 Showcase for Web Developers, or as we like to call it, the WOW.
And the how.
My name is Arne Roomann-Kurrik. This is my friend, Eric Bidelman, and we are Chrome Developer Relations. And what that means is we wander the earth like the Incredible Hulk and help out developers who are writing apps, extensions, and websites for Chrome. So basically what we do is talk about HTML5 a lot. You can see our Twitter handles. We're up there. Oh, actually, let's go back there. Sure. Our Twitter handles are actually up here. Follow us if you want. I like to post updates about Chrome extension APIs and kind of updates to Chrome. Eric likes to post pictures of cupcakes, furry animals with mustaches, that kind of thing. Whatever floats your boat. So a year ago, I was actually up on a stage at Google I/O and talking about HTML5. And back then, it wasn't kind of like the huge buzzword that it is today. It wasn't so overused. We talked about a lot of different technologies. And if you were lucky enough to get a seat, you learned about Canvas element, audio element, video element, local storage, web SQL database, worker threads, drag and drop events, desktop notifications, new CSS styles, CSS transforms, CSS transitions, CSS animations, maybe hotel restaurant management, web fonts, flexible box model, and some of you got your associate degree in building a Paint application or accounting. In all seriousness, we're just kind of doing this to emphasize we covered a lot last year. The video is still online. I think it's a great resource, and if you followed that bit.ly link, bit.ly/HTML5IO 2010, you can actually see it and give a kind of a ramp up on this. So. But today, we're not going to really do that. We're not going to cover the basics. In fact, we just want to show you some demos. I'm betting these demos are actually going to make you say some amazing things. What are they going to make you say, Eric?
Wow.
Yes, they're going to make you say wow.
Hopefully.
Hopefully. We're not there yet.
So we're also going to, like I already said, we built these demos, but these are complex demos. These are a lot of HTML5 capabilities working together. And this whole entire slide deck, right, HTML5 app, all the code is going to be under html5wow.googlecode.com. All the demos, all the slide deck. I just want to mention there's feedback links, there's Twitter handles at the bottom, there's a moderator link if you have questions during the entire presentation. Go ahead and reference those.
Yeah, that feedback link is live right now. You can give us feedback on certain points in the presentation, that kind of thing, so we'd really appreciate it if you took the time to kind of rate us and how we're doing.
Yeah.
But OK, so today we have 3 different topics in our presentation. We're going to break it down. Basically, we found different categories that would work out for us. So file, graphics, audio. But without really going too deep into that, let's start with the first one. Eric, I'm going to hand it over to you and talk about file APIs in HTML.
Absolutely. Thank you, Arne. So let's talk a little bit, before we dive into the file capabilities of HTML5, let's talk about binary data in HTML5. Because the truth of the matter is we're dealing with binary data all the time, right? Web applications, music applications, photo applications. And so it was very, very painful before. This is a little snippet. I call this black magic. You can call this a hack or a trick. But what we had to do to pull down an image as a binary file was use XML HTTP request, right? XML HTTP request. And then have this little override MIME type. Arne is going to highlight certain sections of code. Set it the MIME type to text plain, user-defined char set. This is well documented. We've been doing this all over the place. And then inside of the ready state change, right, we process the response text just as a binary string and do some crazy character code manipulations, hacks, string manipulation. This stuff is hard and it's very error prone. And luckily with HTML5, we have better tools now. So we're going to cover a few different topics. So how do you import data? How do you import files into your application and then do something useful with them? You don't have to import, you can create. So there's interfaces now in HTML5 that you can use to create binary data on the fly. Manipulate existing data. So there's actually new data types that we can use to manipulate this data. We can store that data. IndexedDB, Filesystem APIs, we're going to cover those. And then publish that back out to the cloud. So XHR, you don't have to just send strings anymore. You can send files. You can send array buffers. You can send form data types. So binary data hearts HTML5. I'm not going to cover typed arrays today, but these are very important. These are we're introduced by the WebGL specification, and these are very more performant. They're going to be used to work with binary data file types. We're using them all over the place within the presentation. And so what the browsers can do is optimize based on your data types. So you have an 8-bit array, you have a 32-bit float array. These are all over now. So I don't know about you, Arne, but if you remember the snippet before, right, we did the character code hacks with the XHR. This looks much cleaner, right?
Looks really good.
Yeah, so I want to point out a couple of portions of this. XHR has been extended, and the first thing, the way it's been extended, is the response type. We don't have to pull down our data from the server anymore as a string. We can say, hey, give me an array buffer, give me a buffer of bytes that I can process as the response type. We don't have to listen for the on-ready state and do this crazy state checking. We can just listen for the on-load. Give me the data when it's done. And here's a great example of using a typed array, so an unsigned 8-bit array we're using, and just filling that array with our response. And we're not processing the response text, we're processing a new attribute, the response, and that's going to give us this blob, this image as a binary file. And then you can manipulate that just as a JavaScript array, which is really cool. So that's the new hotness. Without further ado, let's dive into the file capabilities. So the first might not, look new, right? This is our old friend. This is the file input. But the really important and cool portion of this is that one attribute that Arne is going to highlight at the end, the multiple attribute. So if you've ever created a photo application, right, an upload application, you've had to probably instantiate a bunch of these inputs in JavaScript and then send files, your photos one at a time. So instead, we have a little demo of this. This is just a file input that Arne is going to run. And what Chrome is going to allow him to do with this attribute, just one attribute, is select multiple files, not just a single file. So he's going to select a bunch of image files. Apologies, it's so close to lunch. And what you get back is a file list. You get basically an array of file objects. This is a new interface in HTML5 with metadata. So what is the name of this file? What's the MIME type? How many bytes does it take up on disk? When was it last modified? This is really great stuff in order to do some pre-processing or some interesting applications before you send your code to the server. And the code for this, right, I'm just setting up an event listener on the input. And you get back in the target of this event, we'll get a files list. And this is the list of files. And then we'll just loop through those and present the metadata to the user. It's very straightforward, but very cool. Of course, it's not just files. We can actually select now directories using the same file input. So with the WebKit directory attribute, Chrome is going to allow us not to select files, but an entire folder. And Arne is going to demo this. If he backs out of this folder, Chrome's going to recursively traverse this folder and give us a file for each of the files. And see at the bottom here, I'm just printing out that WebKit relative path. So that's also a property on this file object. And we're printing out the files as they appear within this folder hierarchy that you selected. You can see there's a few folders within this folder. Of course, that's cool, but we can also use a little bit of string manipulation, a little bit of JSON, and a jQuery plugin to present that as a sort of a file hierarchy and a tree structure. And so he's just navigating. This is the exact folder that he selected as it was appearing on disk. Cool. Very exciting stuff. So you can upload an entire folder now. You can import using the file input. That's our old friend. You can also use drag and drop. So HTML5 has native drag and drop capabilities now. And so Arne is selecting image files, right, from my hard disk. And he's just going to drag those onto the web application using HTML5 drag and drop. Chrome allows this. And at the bottom there, we read the image files as data URLs, and then we just set an image source tag, applied some nice CSS3 transitions, transformations, pretty cool photo gallery there. But the code for that, right, a couple of lines, and we have the ability to actually import files into our app using drag and drop. Nice. OK, so let's see all this sort of working together. So this is soon to be a photo gallery application. And what we've done here is I'm going to describe this, and Arne is going to sort of drive it. Basically what he did, if you want to run that one more time, Arne, sure. This is going to send an XHR. It's going to pull down a zip file. All on the client, it's going to uncompress that zip file and then read the image files from it. This is using
activating 400,000 devices on a daily basis.
This is using typed arrays and some of the new capabilities of XHR. And then, of course, we applied some CSS transitions and transformations here to present the photo gallery.
How fast we're adding these new users.
I'm getting hungry.
Last year at Google I/O, we announced that we were.
I guess we're competing for your attention. Sorry about that.
So what that means is
that's strange.
Yeah.
So just to show you what's happening, that's an HTML5 Progress Bar that we're updating. That's a new tag as well. And then we're unzipping the file. You can see the uncompressed output there. So the blueprint for the photo gallery, not too complex. There's the SHR stuff. There's a web worker that's doing the decompression. I'm not going to go into the code of it, but again, it's going to be available on that project page. We'll share that link again at the end. All right. So that's importing files. That's how you get data, binary data, into your application. Now, how do we use it? What can we do with those files? We saw the metadata. Of course, there's the file reader object. So this is going to give us the ability to asynchronously read the file into memory. And we instantiate a new file reader object, and you can pick your poison here. You can read it as a binary string. You can read it as a data URL. These are really handy. Read as a text file, or just give me the raw bytes. Fill up an array buffer. And you're passing the file object or the blob, and that's just the same one you got from the drag and drop event, the same one you got from the file input. At the bottom here, we can see that we can actually slice and dice this file. So a good example would be something like Gmail, right? You have this huge attachment, and you don't want to just send one request. You can cut this file up into multiple chunks, spawn off multiple AJAX requests, and then put the file together back on the server. So a lot of really cool options for you. Of course, we don't have to just read the file. If we just want to use the file, right, we can use a data URL. And some of you, most of you are probably familiar with data URLs. I'm not going to cover them too deeply. But the basic format is data : you can construct these on the fly, the MIME type, and then we'll base64 encode the content, the string content. So if you use the file reader object as a string, a binary string, you can use this and present that to the users.
Hey, Eric, what's this function here?
Yeah, so B2A is a new method that the browsers have implemented to base64 encode data, string data. So you don't have to use a library anymore. That's great. Just want to point out, Arne just opened a link, and what he opened was a data URL. We haven't base64 encoded it. You don't need to base64 encode in the content. If it's not binary, you don't have to. So he opened up a text HTML data URL, and it's basically just a text area with some styling, with a placeholder, border radius, right? And so we constructed a cloud IDE on the fly, and let's see if we can, Arne, see if your code compiles. Yes. Nice. So that was a link that he opened in the browser. You can share data URLs. I can email him this data URL, and he can open it in his browser. So they're persistent, one less network request. That's great. And then the downside, though, is the 30% overhead. So if you have binary content, a large file, you're base64 encoding that, you're going to add some overhead. However, come in the create object URL. So blob URLs are something new to the web platform as well. And basically, there's this new method, window.url create object URL, and you pass it the file object. This is the same file object you got from the input file type or the drag and drop. And then you call this, it'll create this blob URL. And the scheme for that is sort of blob, the origin of your application, and then this random hash that sort of the browser or Chrome creates. So I can't share this. Like, I can't send a blob URL to Arne because his browser's not going to understand it. This is generated by my browser. I just want to point out, if you want to bring up the About page for this. So there's some really handy pages in About. These are all Chrome's About pages. And there's one for blob internals. These are all the blob URLs that we're creating. So we're actually using these all over the place in this presentation. And so you're actually instantiating a memory reference every time you do this. And there's a revoke object URL that be sure to call. So this doesn't come for free, but you can see you can remove them on the fly. So that's pretty cool. So they're temporary. They're a handle to the content, right? They're not the content. A data URL is the content itself. These are just a handle. But you can use these as a source attribute. You can use them as an href attribute all over the place just to use the file. Very, very handy. So a really neat example of using a blob URL is the Inline Web Worker. So normally, right, you instantiate a web worker with an external JavaScript file that has all your worker code in it. What we can do instead is inline our script tag, our code inside of the main application. And we'll just use, instead of text JavaScript, we'll use JavaScript worker or any other MIME type, as long as the browser's not going to parse that as a script block. So there's our worker code. And at the bottom, in our main application, we'll use the blob builder API. So the blob builder is going to allow us to create blob data, basically a file on the fly. We'll append the inner text of this script tag inside of that blob builder. And then we'll call our worker by creating an object URL. So we'll pass it this handle to this file we just created instead of referencing an external JavaScript file. So very cool example of using the blob URL. So what's the support for this? Actually pretty good. All the file APIs, Safari, Firefox, Chrome. You can see IE and Opera are sort of semi-transparent, semi-tilted there. And that's because they've both announced at various levels support. IE9 has a lab, and then Opera has announced recently that they'll support a lot of these file APIs too in their next release. Nice. All right, so that's importing files. That's getting stuff in. That's manipulating it. Now what can we do with it? We can store it using the Filesystem API. This is a brand new API in Chrome that we've implemented, and it allows you to do read-write access to folders, files on this sandbox file system. So there's a new property, a call that you can make, request file system, and you pass it persistent storage or temporary storage based on your application's needs, the size of your expected sort of sandbox that you're creating. And this a complete API is asynchronous. So you're passing callbacks all over the place. You're passing in a success in most cases, and then an error callback in case something goes wrong. So really easy to open this sort of rewrite access in Chrome. Of course, once you have this open, a good thing to do would be open a file or create a file. So you can obviously fetch a file, or we'll create this log file, for example. So in our callback, in our success callback, we'll get this fs, this root object. This is just a directory object representing this sort of hierarchy of our file system that we're interacting with. We'll pass it the file name, log file. This options parameter will be create, so we'll just create it if it doesn't exist. And then what we get back is a file entry object. And the file entry object has various properties on it. So what's the name? What's the full path in this sort of hierarchy that we're creating? Is it a directory? Is it a file? The really important one here is the file entry.file. So you can call this method, and what you get back in the callback is actually a file object. So again, the same file object you saw in the input file, the same one you saw in the drag and drop. This stuff is appearing all over the place, and there's a lot of interop between these different APIs now. And then Arne's highlighting various other properties that you'd expect from a file system, right? Copy, give me my parent, move, remove. It's a very powerful API. I want to just quickly point out that you can write files too. I'm not going to cover this code, but there's a file writer object that you create. So once you've opened the sandbox file view, you create this writer, and then you can write that file object to this file system. So without further ado, let's show this stuff in action, because I think it's worth a demo. All right. So this, I introduced you to the HTML5 terminal. We've replicated a shell, basically, in HTML5, thanks to the Filesystem API. We've wrapped the API's calls with familiar Unix commands. So this is just a web application. Arne can ls. So we have one file in our file system. He can add more, of course, using drag and drop. And we're just writing these using the file writer API. Let's do an ls again. Boom. Let's look at some food, Arne. I'm getting hungry.
Really?
Yeah.
OK.
All right, we'll open a burger. Delicious. So this is just opening it up in the browser. We have an open command. We can cat that file, or we'll cat a text file. This is using the file reader API to read the contents of the file. Oh, HTML5 audio. So Arne makes a few mistakes. We can implement a bell sound when he presses delete.
Just so you know.
Yeah. There's theming. So we've implemented some basic theming. Let's change it to cream. Cool. If he presses refresh, this is using a local store, just going to save his theme. I don't know if you want to save that preference. I like the black personally myself. What else do we have, Arne? You want to, zoom in a little bit on that. So this is just using Css3 and animation, and it's just replicating a CRT sort of monitor. I don't know. It's completely superfluous, but
yeah, it's the most gratuitous thing I've ever seen.
Yeah, sometimes you got to take the extra step. What else? Oh, wget. So we can do HTML now has the ability to do cross-domain XHRs. So we can pull down html5rocks.com and just read this and print the source code to the terminal here. So I think that's it. Is that it? All right. So that is HTML5 terminal shell. Again, Filesystem APIs working together. We'll bring up the blueprint. A lot of stuff going on. So we installed this application as a Chrome Web Store app that I didn't explain. The Web Audio API, file drag and drop. We'll cover some of this in a bit. But very cool, thanks to the file system. So that's 1, 2, and 3 ways now to generate URLs. You saw Arne, when he typed open, the burger picture open. That is using a new URL scheme. So that's the file system URL. That goes along with this API. So you have blob URLs, you have data URLs. A third way to use a file just directly is a file system URL. So you can call the file entry.to URL to get, Arne's highlighting the scheme of this. This is what you get, is a file system : the origin of your application, and then sort of the relative path within the sandbox. And you can append that to DOM, use that as an image source, an href, a script source. So very cool. You can take your entire application offline in the file system. There's a resolve local file system URL call. So if you have one of these saved file URLs, you can pass it to this method, and then it'll give you a file entry object that you can manipulate with the API. So a lot of back and forth. Cool. So file system APIs, right now, only in Chrome. And this is a particularly exciting API, right? You're going to be storing things offline. You're going to be generating binary files in your applications. We hope the other browser vendors will implement this relatively soon.
So Eric, you're telling me that with this really advanced API that's coming out and really kind of people are working on it, the best you could do is a terminal that looks like it's from the 70s?
Yeah, we took a step backwards in computer graphics, didn't we?
Yeah, we really blew the goat on graphics there.
Yeah. Do you have anything that can?
Yeah, I think I have some stuff prepared. Do you want to jump into that?
You do. Fantastic.
Yeah, I just in case.
All right. I'm going to turn it over to Arne.
OK, so I'm going to talk about graphics on the web. When we're talking about graphics on the web, there's a lot of different approaches that you can take to get basically the same effect, which is basically drawing something onto the web page or animating something over time and making it kind of move. There's 3 different approaches that I like to take when I think about this. The first is declarative. Just tell the browser what to do, and then it does all the heavy lifting for you. Otherwise, I could script things. I could actually do the drawing myself and do like animation frames and that kind of thing. Or there's even low-level access to hardware, and we'll talk more about those. But starting with declarative approaches. When I say declarative on the web, most people think CSS. I just want to kind of talk about SVG for a second here. SVG, if you're not familiar with it, is a vector file format that's kind of specified using XML. What this lets you do is draw lines and shapes and fills and use styling and all that stuff in a way that actually is, first of all, human kind of readable, human constructible, and then second of all, scales with resolution. So if you actually show this path that I'm kind of running here, and you can actually see on the right, we have a raster version of that same path. And you can definitely see that there's a quality difference between the browser kind of rendering an SVG because it's using vector scaled up to a larger resolution versus a bitmap, which is just pixels and kind of stretched and blurry when we blow it up. So moving on, SVG has a great kind of property of having its own DOM. So just like the web page has its own DOM, the image has its own component elements that you can change and modify, and the browser will do all the rendering. So you can see here that Eric is selecting some text that's been applied to a path using SVG. That's amazing, because we can define the path, and we can define the text, and the browser just takes care of all the rendering for us. And the great thing is that we can actually wire it up with a text input, and as Eric's demonstrating right now, we can actually change the image dynamically. Think about how powerful that is. Nice roller coaster. Think about how powerful that is if you need to localize we into 40 languages or whatever. Or if you want to do things like have screen readers be able to access the text in the image and so on. The great thing about this is that this SVG syntax is actually in this page itself. We're not referencing an external file. The SVG notation is actually part of the HTML5 document that we're loading. And you can do that. You can just put SVG tags in and then put SVG notation in between. But going back to what I mentioned before, most people think of CSS when we mention declarative stuff. There's so many new features in CSS3 that I really can't possibly cover them all in a single presentation, or even a section of them. So here's just a bunch of interesting things. But we're kind of focusing down here. So let's talk about one of my favorites, the animation keyframes tag. And you can see here that we have a spinning Chrome logo. And the way we've defined that is actually having this new keyframes notation. And we specify a from state and a to state. And then when we want to apply that animation to an object on the DOM, we just basically say which animation, how long is it going to take, how many times do you want to do it. And then we have this kind of cubic Bezier function here, which lets you specify how the animation behaves. And this is really great because it shows you how powerful the declarative approach really is. Why don't we kind of open up a little bit more into that? So what we have here is a little tool that we've kind of done to represent the timing function. Eric, why don't you load the linear timing function right now? And there's some presets that are available as part of the spec. And you can see here that the linear kind of just rotates the circle at a constant rate. Now open up ease in out. And if you do that, it'll be slow, and then fast, and then slow again. So again, you have these presets that let you kind of dictate how animation works. If you're familiar, well, if you've been watching the slides, you've actually seen the rotation that we've been doing, and that's all done using this kind of syntax. So it's kind of has a little bit of a shape to it. Of course, you can specify custom points. So Eric here is kind of defining a custom animation. It looks very strange. I don't know if anyone would ever use that.
I'm using that in my next app.
Okay.
That one right there.
But again, just to show you how as you define the custom function, you can actually get a wide range of different animations just out of a declarative approach. Looks like you're having a lot of fun there.
Yeah, sorry, we'll move on.
OK, so another kind of unsung hero of new CSS stuff, I think, is 3D transforms. And we really like this because hardware acceleration is now being featured prominently in some more browsers, and we're really getting some interesting stuff out of it. And you see that the slides themselves have a 3D effect to them. And we're doing that all in CSS. So just to show you how that kind of works, we have two nested elements here. We have a green box surrounded by a blue box. And as Eric's showing, you can just select the number inside of it. It's just DOM, divs. And if you actually activate the next sample, what we're doing is we're actually rotating the green box out 45 degrees along the x-axis. Now, x-axis being from left to right, you can actually rotate out on that plane and by applying a CSS transform. Now what we're going to do is rotate the parent element. And we actually rotate it along the y-axis, so it rotates kind of away from the viewer. And what's interesting about that third example is that it's not popping out of the parent like you would expect it to. Looking at the second element, if you saw that rotated out, you would expect that to kind of have its own coordinate space. And the reason for that is that by default, CSS kind of maps the 3D transform against the flat plane of its parent element. But you can break that. You can actually construct models and objects in 3D by applying this preserved 3D transform style onto the object itself. So it lets you create 3D models using CSS notation, which is fantastic. It lets you do some really cool stuff. Let's put some of this together. So we have our old friend, the spinny Chrome logo guy. And what we're going to do is build up a DOM. So we have a container element, and we're rotating that on its own axis, so along the y-axis, kind of slowly. And then we're going to start putting panels into that DOM. And those panels are each rotated 90 degrees off of each other. So you can see here as Eric kind of unhides them, they're actually building up a model in 3D space that's rotating around this Chrome logo that's in the center of that container. And so they all get the inherited rotation of their parent element. And all we have to do is really just specify how they interact with each other in space. Now, it'd be really cool if we could do some interactivity in this model. So the same way that you would take a hover state for maybe a link, an anchor link, we can actually have a hover state for each of these DOM elements. And then we apply a transition between them, which tells the browser just if you ever change one of these properties, just animate it linearly or whatever. Then we can actually have a fully interactive model that's defined entirely in CSS. There's not a single line of JavaScript running this demo right now. That's really powerful. You just kind of define the constraints, and the browser takes care of all the rest. So let's move on. Of course, sometimes you do really just want to script something. Sometimes you just want to draw something. So we have the canvas element. And this is kind of like an image tag that gives you a JavaScript API that you can draw onto. And you can do some really cool stuff. Like, for example, what we're doing here is just drawing kind of the state of a model that we're running. And then we're clearing it. And then we're drawing it again and incrementing the model itself. So we're getting an animation because we're just drawing a bunch of frames. Yeah, you can move on.
All right.
So, but what do we do when we're doing animation? Well, we would normally just have a loop running. We'd use this, probably one of my least favorite JavaScript calls, window.setTimeout. And we'd be calling the draw function over and over again. And the reason why I don't like window.setTimeout, well, one of the reasons is that you specify milliseconds onto this function. We have 10 here. And you can see that the animation is actually only running at about 20 milliseconds. So first of all, it lies to us. This is the most untrustworthy function because it doesn't actually get called when we ask it to. The second of all, I don't like it because most people do drawing inside of it, but the browser doesn't know that we're doing drawing. So what happened is some really smart folks decided that they wanted a new function that would be specific to animation, and they introduced the request animation frame function call. And why don't you switch over to the new hotness right now?
New hotness. Wait a second, nothing changed.
Yeah, that's a very good observation, Eric. Yeah. This is actually because it kind of behaves the way that setTimeout was demonstrating, but now we have a contract with the browser. And the contract is only call us when we want to draw something. So when the browser is ready to draw, it calls us, and then we do our little update, and we say how many milliseconds it's been, and then we move on. So we're happy with that. But let me show you how the browser can optimize this a little bit. So if Eric's going to kind of pull out of full screen mode here, he's going to open up a new tab. And what we have is the title of the existing tab kind of updating in time as the animation frame call is happening. So if you zoom in there, open up a new tab and focus it. OK, so this call has actually been frozen. And the reason for that is because the browser knows that we're doing animation in that callback, and it doesn't bother calling it when the page that we're trying to do the animation on is not visible. This is really powerful for things like mobile devices, items with a limited CPU that might want to run multiple demos, maybe even battery life, that kind of thing. So why don't you go back and show them what happens when you use the old approach. So we're just going to switch back, again, using Windows set timeout. Remember that we're requesting 10 millisecond updates. We're not getting that. But then when you open up a new tab, it still updates. Now, Chrome is actually really efficient in this case. It understands that the tab in the background might not need to be updated as often. So it actually slows down the interval, the minimum interval for Windows set timeout when the tab is not active. But you can see it's still being called, and that's once a second that you might be drawing a complex 3D model or something like that. So again, the request animation frame just kind of helps us have a contract with the browser and really just kind of enforce that contract and allow it to optimize itself further. So moving on, you have this Canvas API, you have this request animation frame, and then you have this great draw image function. This isn't really anything special, but what I really like about it, what a lot of people don't kind of realize, is that you can draw anything from any kind of image element, including images, other Canvas elements, or even web video, HTML5 video, into a canvas. And you can actually do things like draw sections of an image. So you only need to load one image if you're doing an animation function. You can see here that we have a whole sprite sheet. And what we're doing is we wrote a little bit of a game that's just kind of animating it and drawing it over and over again. Just to show you how responsive this is, Eric's kind of drawing with his mouse this terrain. Little Chrome man here is jumping up and down. Oh, you're giving him a hard time, man.
He needs a workout.
OK. But just to show you, again, how powerful the Canvas APIs can be, how performant they can be, why don't you click on that background a little bit? Kind of scroll down. You can see we're drawing a full motion video directly into this. And we're still maintaining that same fluid frame rate. And it's all done in JavaScript, all done using the Canvas tag. But it just looks really cool. And like, there's a lot of potential there to do things like 2D games. Of course, you know, the last time I played a 2D game was a while ago. Yeah. Well, no, that's not true. I played Angry Birds the other day.
Nice.
But you know, kids like the 3D now. I'm sure we'll see something in the future, like 3D something.
TVs?
TVs, yeah. But yeah, so we have 3D support in the browser now because the kids like 3D. So anyway, Eric, I think we have a demo of what the future of 3D in the browser is.
I think we do.
Any of you guys who might have gotten lucky enough to have some glasses?
Now's the time if you were
lucky enough to show you,
score some glasses.
You know, every time I go to the theater now, I need to put on these glasses. So we just figured Chrome's just going to support that as well.
Absolutely.
All right, Eric.
Yeah.
Activate the demo.
Activating demo.
OK. And now activate the motion controller.
Activating motion controller.
Oh, yeah. Yeah, this is welcome to the future of 3D in the browser. Ooh. No, I'm just kidding. This is actually not the future of 3D in the browser. We're actually just demoing another input event right now. Just kind of threw it in there. It's the device orientation event handler. And this just lets you kind of just have you know, any sort of piece of hardware that's running your browser, like a mobile device, in this case a MacBook, which has a tilt sensor in it, can actually send events into your DOM page. So you can use this for, you know, more game inputs or things like that. Really cool with animation, really cool when you're running models like this. Hopefully you guys are seeing some 3D effect there. But we actually do have a real 3D support. We don't need glasses for it. And we're calling it WebGL. And this is a variant on OpenGL, actually OpenGL ES2, which is the same sort of technology that you'd use to program 3D in like a mobile browser or a tablet. And you can run this directly in the browser, as you saw in the keynote today. So again, just show them how dynamic that model is. And we're responding to DOM events because WebGL is actually scripted through JavaScript, so we can take advantage of all the DOM kind of event model and all that stuff to have input into our games or simulations or whatever. And you can see up here the code snippet is actually a WebGL shader, which runs on the GPU itself. So it gets uploaded to the GPU, and it runs on hardware. So you can see it's very fluid. It's very dynamic. You know, this isn't the greatest demo, so let's see a little bit of a better one.
Absolutely.
You can see here that we're taking a Chrome logo, and we're just deforming the hell out of it. And yeah, as Eric's kind of pushing those pixels around, keep in mind that this is running on the GPU of the MacBook itself. And we're kind of getting this really cool animation, really cool visualization. Again, just using that power of JavaScript and hardware shaders. So again, we saw a really cool demo in the keynote of WebGL. Don't really need to spend too much more time on it. Probably a little bit too complex to go into here. So why don't we see if we can maybe improve the command line a little bit, though.
OK, let's take a look at that again.
OK. So yeah, is there any command we can run to kind of give it a little bit more style?
There's a 3D command.
Yes, I like that.
You can try that one. Let me run the special populate command first. Let's try 3D. Hold on to your butts.
This is Unix. I know this.
Whoa.
Whoa. This is awesome.
Arne and I are big movie fans, if you can't tell. So yeah. You want to explain what's going on here?
Yeah, actually, I'm getting a total vibe that this looks like two web applications communicating via window.post message and sending messages back and forth.
It sounds like somebody built this.
Actually, yeah, so I think that's exactly what we're doing here. We have the same terminal application. We have a WebGL simulation programmed by Ilmari, one of our awesome coworkers. And what we're doing is we're actually just sending window.post messages back and forth between the iframes that are kind of running each of these demos. You can see here that the simulation is WebGL. It's running really fast. It's dynamic. It's responding to Eric kind of doing some, oh, looks like you're in your home directory.
Found my
buddy.
cupcakes.
We found his secret stash.
Boom.
Yeah. That's really cool. But yeah, very dynamic, very smooth and fluid.
Wait, but Arne, there is a curious top secret directory in your user directory.
What's in there?
It says HTML4 rocks.
Oh, no. Delete that.
All right, let me get that.
Yeah, we don't want that. They told us to get rid of confidential stuff in the...
You know, it's not letting me for some reason.
Oh, I know this. This is Unix, so use sudo.
Oh, OK, I'm going to try that.
Oh, no, close it. Shut it down.
Shutting down.
Yeah, so we again have a blueprint here. Image is broken. But anyway, we use window.post message, WebGL to do the rendering and all that stuff. Now, Eric, you were playing some interesting, there we go. You were playing some interesting audio at the very end of that.
We have an audio section.
Oh, amazing.
Yeah, I too have prepared some content. So yeah, so the whole multimedia story wouldn't be complete without talking about audio, right? And many of us probably know HTML5 also is BFF, best friends, with audio. You're seeing a lot of this theme come up. What we can do now, though, is be able to play things from the Filesystem Api, right? We write audio to the Filesystem Api and play it. We can generate audio. So there's a new API that we'll talk about that you can use to generate audio in real time in JavaScript. If you don't want to generate it, you can analyze an existing sound file. So this is really cool for real-time analysis of playing music. So I just want to quickly cover, right? Everybody knows about HTML5 audio. There's an audio tag. It's native to the browser. There's no plugins. This is really exciting. Pass it your source files. All is well and good. This demo is probably the least sexy you'll see today, but this is illustrating a really cool concept, and that's being able to generate audio using the file APIs we talked about. Arne is going to generate WAV files, WAV files. This is the same file system that we opened with the terminal, right? So all the images are still there. He's just generated two WAV files using a nice JavaScript library for that, using typed arrays. Go figure. And then we can play that. These are stored in the file system, and you want to scroll up a little bit.
Yeah.
We're playing that, we're saving that data, those files, to the file system, and then reading the file system URL that we talked about, and then rendering that, just populating the audio source tag with that URL. So a really nice example of this stuff working together very nicely. So that's HTML5 audio, but I really want to focus on a new API in Chrome, which is the Web Audio API. So the way this API works is that you basically have this audio context that you construct, very similar to Canvas, actually, and you manipulate the sort of nodes and system as you go. So if you just wanted to play a sound, of course, this is an API for sound, so we can play a sound, go figure. But you create this audio text context with this new property in the window object. And then if we're just going to play a sound, we just want to construct these nodes. So we're going to construct a source node and just pass that off to our destination. We're just going to play the sound. And the way that works is by creating a buffer source. So we'll pull in our MP3 file or our audio file using XHR. And then we'll populate the buffer with that array buffer data that we got. And then we're just interested in playing the sound, so we'll connect the source right to the destination. And then calling note on at time 0, we'll just play that immediately. So it's a bell. Not too exciting, but we can use this exactly as we would HTML5 audio. Let's see something more interesting. So generating sound. This API allows you to generate sound inside of JavaScript. I'm using dsp.js. That's a library that was written for the Mozilla Audio API. They have their own API. But you can use that also with this API in Chrome. So I'm generating a sine tone. And instead of loading up an audio file, we're just going to pass that off. We're going to create a buffer, pass that buffer, that sine wave, off into our API, and then connect, again, the source to the destination. We're just going to play this audio file. At the bottom here, we have 2 canvases. So Arne's going to play around with frequency. This is all real time as he's doing this, and Chrome is generating the sound. And we're rendering that frequency data out to a canvas tag, just the oscillation. So you can change different types using that dsp.js library. What's happening on the right is actually a web worker. So we're calculating the FFT, right, the spectrum of the audio file, the audio sound on the right side. So that's why there's a little bit of a delay. We're passing that data, it's doing the calculation, and it's coming back, then rendering that out to canvas. Having fun?
Always.
All right, of course, we can generate sound, we can play sound, but what's really, really amazing about this API, the Web Audio API, is you can analyze existing sound. So I kid you not, in 10 lines of code, maybe 11, 12, depending on what you're counting, you can analyze a sound file and then present that to your users with some kind of visualization. So we'll do the exact same thing. We'll create an audio context, but this time we're interested in analyzing it. So we'll create an analyzer node. We'll create a JavaScript node. The JavaScript node is going to fire events at us, and we'll be able to process, as audio is processed in the system, we'll be able to take that and do something with it. So in that event, Arne's going to zoom in here. Do you want to just highlight the portions of code too? Press H? Mm-hmm. Cool. So we're using a typed array. Again, this is going to be more performant for us. And the frequency bin is going to be filled by this get frequency data call. It's going to fill this array with frequency data. And then we can use that, and we'll see a couple demos of that for a visualization. But the same thing again. We're just connecting these sort of blocks that we're creating. So we'll create our buffer. We'll load it, the file in. And then we'll connect source to analyzer, the JavaScript node that gives us the events, and then the JavaScript node to the destination. So let's see a demo of that.
Wait, you're going to show them the prototype?
Yeah. Is that OK? We're working on a new computer.
Well, last time it didn't work out so well.
Oh, yeah. Well, yeah, let's show it anyway.
OK.
All right. So this is Gal 9000. This is a new prototype, another operating system Google's working on. But if you want to zoom in on this, so this is just a div. This is all markup with rounded corners, linear gradients. And I apologize, it looks a lot better in the laptop. But he's got a radial gradient. It's producing that red-black effect, and the dot in the center. Multiple backgrounds, right? Actually, the only image on this page is that reflection at the top. You're probably wondering what this has to do with audio.
Good afternoon, gentlemen and ladies. I am a Gal 9000 computer. I became operational at the Googleplex in Mountain View, California on the 4th of May, 2011. My instructor.
All right, so we created artificial life form that can talk to us. This is actually Arne's voice. So we've loaded up an MP3 file. And what's going on is as this file is playing, we're analyzing it using the API, this Web Audio API. In the center there, you can see his voice. And that's a canvas tag. So we're rendering canvas based on the amplitude of each of the samples that we get. And that's what's doing the flickering. Also CSS3. So we're changing the radius of that CSS3 gradient. And that's what's sort of producing that effect on the red to black.
The Web Audio API
It's cool.
is really quite nice.
I like it.
All right. Turn off the prototype.
I'm afraid I can't do that, Eric.
Nice. So that's Gal. Again, Web Audio API, Canvas. What else? Typed arrays. Again, this stuff is showing up all over the place now in these complicated APIs. So let's see some more visualizations we can do using the analysis portion of this API. Go ahead and press start. I'll sort of talk through this, but also I want to, it's audio, so we got to listen to it too. Arne's you gonna DJ?
Yeah.
All right. Arne's gonna DJ this. This is analyzing the sound file on the fly in real time, and then we're just rendering each of those bins. We're looping through that typed array, and then rendering that to canvas. There's this cool little half circle. That's a filter, an SVG filter over this canvas element, and a gradient, a mask, a CSS mask, excuse me. Let's go ahead and hit next. Boom, Css3 Animation. It's just canvas, so we can change the coloring of what we're presenting, change the gradient there. Arne, do you want to go to the options and play around with it a little bit? So again, we can render this data any way we want in Canvas. You don't have to use Canvas. You can use WebGL. You could use CSS3. You just saw a demo of that. So we're just presenting it in a different way, and we've had little inputs. We can do time or frequency domain analysis. So this is the time domain analysis. You can speed up the playback rate. Go ahead and do that. That's kind of cool. Nice. Let's go to the next visualization. OK, so this is the HTML5 logo. Again, canvas, but it's been overlaid with the HTML5 logo as the WebKit mask there. We can take that one step further. Arne introduces some really great transformations in CSS. So we can apply a 3D transform to this entire thing, and in real time, it's still going. There's a little bit of flicker, and we're using Chrome Dev Channel, so it's bleeding edge stuff here. Go ahead and show us the next visualization. All right, so Chrome, little beat detection library. We can beat detect Chrome. CSS reflection on the bottom there, kind of a cool effect. Oh, all right. Do we have any? You're having fun by yourself? Can we invite some people to this party? We have people streamed in and everyone in this room, but
I get an idea. I can invite my special guest.
All right, let's see what we can do.
OK.
Bug Droid.
Yeah. Bug Droid.
Bug Droid. We can animate Bug Droid. He's just markup as well with rounded corners. His little ears are going. His legs twitch, and he's really getting into it. Just using Css3 transitions and animations. But if we turn this up, if we get really excited, Bug Droid can do the fist pump. Yeah, so again, just CSS and using the API to analyze the sound file on the fly. I'm just getting that data and sort of rendering it as the amplitude changes. All right, so that's yes, thank you. So that's the web audio API. I only showed you a small portion. There's effects, there's panning, there's convolution, there's all kinds of stuff. You can imagine when you have microphone access, the device API, when that comes out, the ability to talk into a microphone and do auto-tune in the web browser. I mean, that's going to be really cool. So support right now just Chrome, but Firefox is sort of, actually I didn't tilt it, but Firefox has their own API. And a lot of these demos I just showed you actually work in both of the APIs. So they're very similar, but again, with differences.
I don't know about you, Eric, but I'm full. I'm stuffed.
Full on what?
Knowledge. Not
knowledge. Food. OK. Yeah, that was a lot of stuff. We went pretty quickly. 13 minutes to spare. So let's just sort of recap what we covered, because we did cover a lot. Bleeding edge stuff in Chrome, all available in Dev Channel today. First, I started off with the file APIs, right? How do you get binary data in the cloud or in your application? How do you work with it? How do you manipulate it? How do you store it using the Filesystem APIs in the terminal demo?
Then I talked about graphics. Again, the three approaches that I like to think about. Declarative with CSS and SVG. Scripting with JavaScript and the canvas element. And then accessing low-level APIs through WebGL. Yep.
And then I rounded out the picture with the multimedia story. Put gold in your pocket with the web audio API. There's going to be a lot of great stuff that you can do with that API.
A lot of gold in your pocket there.
A lot of gold. You might not be able to walk out of here.
We have a lot of resources. Again, they're all linked to from this presentation. You'll find links to the presentation after the session. We have it all hosted on a code hosting project and all that stuff. We have it hosted at HTML5, 5 being spelt out, FIVE, wow.com, but it's not open yet. We'll turn it on after this, after we get done. Yep. Once again, please, find the feedback link. It's goo.gl, AC8N7, all lowercase. We really appreciate the feedback. We get kind of a mandate to come back again and do some more crazy stuff if you guys like us. So I think that's it. Yeah, thanks for being a great audience. I'm going to launch this moderator.
Yeah, go ahead. Yeah. Go for it.
Time for questions if people are interested. Oh, geez.
Go to view questions.
Oh, yeah. Nice.
So go ahead, if you have any questions, step up the mic. We'll just start rattling off the moderator questions here.
Yeah. So as as people kind of trickle out, I know you guys are probably eager to get to your next sessions.
Lunch.
Or lunch, yeah. What software to web technology are you using for your presentation? That's actually a great question. We didn't really emphasize it. We're using HTML, JavaScript, CSS. So we just wrote it all by hand. It's part of that open source project, and we'll be happy to go over that. We'll probably post tutorials about how we built stuff on html5rocks.com.
Yep. Do you have a live question?
Yeah. Do you have a?
So you guys have that request animation frame function?
Yeah.
When you switch the tab, it obviously stops, right?
Yeah.
What happens when you hide the element or you set it invisible or something like that, does it stop as well? Or?
Yeah, so in Chrome's case, it doesn't currently, at least from my quick testing on it. But that's part of like the idea behind the spec, so I think it's just not implemented yet. Eventually, it should be that like if you hide the canvas element, you don't need to make any sort of callbacks or change your game code or anything. So yeah, that's exactly what it's intended for.
Yep. So similar question, what slide, how are you doing the slides? Arne covered that. It's all going to be open source, and there are sort of a HTML5, other people are doing different HTML5 a slide deck here at I/O this year, and there's on HTML5 Rocks, there's sort of a template you can use and take that and use that in your own slides as well. But again, this particular one uses CSS3 transforms and transitions. Yeah,
you can hit down arrow and highlight it. Yeah.
In the audio demo, what were you guys using to do the FFT?
Oh yeah.
The FFT is calculated in the API itself. So there's the API call for that.
Oh, awesome.
So the API, I didn't explain it. It exposes a lot of low-level functionality. So if you've ever done the Mozilla API, they have, everything is basically in JavaScript, and you get events. This one, do the FFT, there's a call for it, and panning effects and convolution and all that cool stuff.
Awesome.
Yeah.
Do you know if that'll be offloaded to GPU, like in the future?
Good question. I mean, right now it's all CPU. It's brand new, just landed, so hopefully, yeah, everything should hardware accelerate everything if we can.
Yeah, exactly.
Yeah.
All right, cool, thanks.
I guess we'll do another one online.
Sure.
HTML5 on Android devices. So Google does support HTML5 on Android devices. The Android browser can render HTML5. So I don't know about Marketplace. We don't really talk about Marketplace right now. So I don't know. I'm not sure I follow.
Maybe somebody in the Android section can answer
that
better than we can.
I'm sure that's a good question for like the Android sessions.
Yeah.
Yeah, sir.
And so with the HTML5 audio and video tags, if the browser doesn't support a particular codec, is there extension abilities to install that?
That's actually a good question. Right now, I don't believe so. I think that native client in that case might be an interesting technology to use because native client is like an open source project that Google's kind of helping develop. You can write C code, compile it in a way that's kind of secure, has a sandbox, and just run it on arbitrary like HTML sites. So in that case, if you had a custom codec, you could probably implement it using native client and then draw out to a canvas element or something at high speed. So I'd imagine that would be the approach to take. I don't know of any like extensions that could let you do that.
Okay, thanks.
Sure.
Yeah. Has there, moderator question, has there been any work letting web applications handle multiple windows? If I understand the question correctly, just being able to open up multiple tabs maybe in your web application. There's actually a really great use case for shared workers here. So web workers, but there's a different version called shared workers that you can basically fire up this worker, and it's sort of a background process, if you will, that you can use to manage multiple state, or the same state across multiple tabs and communicate, inter-tab communication.
It's like having an invisible window that can talk to any other window on your domain.
Yep.
So yeah, that's actually really useful for that kind of thing.
Question?
Right, one more question. So you guys were getting file handlers and folder handlers and stuff. Is there any way to persist, folder handler, let's say, through to a next session or through a cache or something like that, so you don't have to get the user to give you the folder handler?
It's a great question. So right now, this sort of HTML5 file system API is a sandbox per app per origin. You can't write files to outside of this location. There is an API that's been spec'd out but it's not been implemented called the File Saver API. So this will allow you to do things like open the users, with permission of course, open the user's My Pictures folder, and then be able to read and write data to that. Right now, it's just a spec. Nothing's been implemented.
And in terms of extending those handlers, or not right now. I think there's I've seen some vague discussion about it. Just it would be nice to have. I think people are going to think about it, but right now the file system stuff is where the focus is being.
And because of the sandbox, there's no way to sort of have the location of the file and without the user's interaction access that folder.
Yeah, not like a persistent handle to some shared directory on your file system or something.
So for example, you saw in the demo, the file system terminal demo, he was dragging in files, and that's how we got him in. So we're actually duplicating. I mean, there's two copies, right? There's the original folder, and then there's the one that we're duplicating into the file system. So there's always that interaction right now. Yeah. Or you can import them if you had the zip file, that photo gallery demo. If that was not local, that was on a server, right? You could download that and then save that to the file system as well. So there's different options.
Okay. Thanks.
Yeah, sure.
Schizophrenic question. Let's see. Rendering HTML5 versus Android apps. Is Google? I mean, we're not in any position to say that. I think Google's supporting both apps to.
Right.
I mean, we've got lots of talent and.
I mean, the beauty of HTML5 is you can run it anywhere, right? They're just web apps, and all these platforms run those.
Yeah.
Whether
and
it be
then
Android
versus
or Chrome,
Android.
or Chrome network, right?
I mean, Android apps are one thing, and then web apps are another. Yeah.
Hey guys, I'm working on a HTML5 game, and in one of your other sessions, you guys recommended using Soundmanager 2. In what instances should I be using Soundmanager 2 or Web Audio API?
Yeah. So it's kind of different use cases. The Web Audio API is going to allow you to do effects on audio and things like that. I just showed you only portions of it, right? Soundmanager is great, right? A great option right now for using sound across browsers. Just audio, there's been a lot of bugs actually in Chrome for HTML5 audio that have been recently resolved. But as far as audio support is concerned, Flash is great. Soundmanager is great. We definitely recommend it. I mean, Chrome can run Flash. Why not, right? If that's the best option for you.
Yeah, I think the major concern that Soundmanager was trying to address was that the audio tag had no contract between when you wanted a sound to play and when it would actually play. Like it wasn't meant for low latency or no latency kind of like audio effects.
Yeah.
So in the case of, so people started using that, and it was really kind of intended for streaming or that kind of thing. So people started using that for sound effects. It wasn't really suited, and that's why we have that other API that Eric was demoing. That it's really kind of more in line with what Soundmanager is trying to achieve, which is like, I have a game and I clicked a key and I want to play a sound right now. So the latency is a lot better, but I think Soundmanager's support is just much wider at this point.
That's really a good point. So if you want your users to use Chrome and use the audio API, this Web Audio API, there's that note on function when Arne is pressing the button, the bell, called note on at time 0. You can actually schedule when this stuff happens. So the API was designed for low latency, things like games, right? Button clicks, beeps and stuff. Sequencers, all that stuff, yeah. So I mean, if you want to stick with that API until it becomes standard across different browsers, there's a specification out there right now, but Chrome's the only one to have it implemented.
Okay, all right, thanks guys.
Yeah.
Sure, thank you.
Again, will this presentation be available? Online summary, yes. HTML5 wow.googlecode.com.
Yeah.
Is Google's Panda algorithm set up to be looking and liking HTML5 compared to just standard HTML? Don't know the details of Google's crawling algorithm. It does understand, Webmaster Tools actually does understand microdata and microformats. I think it presents different things based on what you have on your page, right? If you have like a music site, right, you can do albums and it'll understand that and parse that out. I don't know about the semantic tags. Keep in mind that a lot of this stuff is still changing. So yes, all the browsers now have HTML5 semantic tags mostly implemented. But a good example of this changing is the H group tag, if you're familiar with that. They kind of pulled it out, put it back in, pulled it out. So the specification is still changing until I think that really solidifies and everybody's solidified on something. Then I don't know if Google.com will update itself, but honestly, no idea.
I think, yeah.
What is the link to the presentation? So the presentation itself is html5wow.com.
Where 5 is spelled out.
Where 5 is spelled out, so F-I-V-E.
But it's under a password right now.
Yes,
So
sorry.
as soon as we get off stage.
Yeah, for anybody viewing, it'll be up as soon as we get off stage. The time and frequency domain analysis was amazing. Is that processed via some JavaScript library? So that the time and frequency domain is part of the API. So there's a call on that analyzer node that I created, analyzer.getFrequency data as a time domain or frequency data as a sample domain. And so yeah, that's part of the API itself. So just to contrast, the Mozilla API, I think you have to do all that processing in JavaScript. This one, you basically just fill an array and then use that array. You saw me render that array to Canvas. That's what was going on there. Terminal seems to be awesome. It seems it is awesome. It is available on Chrome Store or GLab someplace. I can find it. Maybe you'll share it. Yeah. So there's a tutorial on html5rocks.com that has a Filesystem API access. And that's sort of the V1 of this. We've definitely done some new stuff and capabilities for this presentation. I will put this up on the web store. One thing that we didn't discuss was you saw Arne at the beginning type install the terminal was installed, and that's installing the application as a Chrome Web Store application. And it actually, that's needed right now, because in order to write data to the file system, you need to have either a flag running on Chrome, unlimited quota, or something like that. Most users don't know how to start Chrome with a flag. So if you have the unlimited storage bit in your manifest file for your Chrome Web Store app, that's what allows you to do the read and write right now. As soon as Chrome expands and it has a sort of a quota system, then we'll have the ability to any web application can use the file system API to write data. So yes, the short answer is I will put that up on the web store someplace.
I think we're out of time, actually.
We out of time?
Yeah. OK, well, thanks again. Thanks for being a great audience.